So welcome back to Wickerson Studios. Michael Wickerson here. I've just completed the first of several videos. However, the first 10 fit to the first AI Copilot to AI Stable Diffusion. And we're now on to another file. So I simply copied that file and I've retained the past script over here, which I'll slowly erase. But what I want to take from it is the title of AI Copilot Stable Diffusion at wickersonstudios.com, Python for data manipulation and mudging. I'm selling those first 10 scripts now for $5, and I'll keep adding to that series. You'll get the GH script, you'll get the 500 lines code, and we're going to extend that code into the second section. And this time we're going to go back to creating ND arrays with hops for Grasshopper and Visual Studio Code. But this time I really started to clean things up and going a little deeper into what exactly I'm working on. And what I'm working on is NumPy Basics, arrays, and vectorized computation into Grasshopper. That's basically what I'm doing. It's taken me this long to figure out exactly what I'm doing, but that's pretty much what I'd take a sabbatical to develop. So we are going to work with a three-dimensional array object. Let's just keep this simpler. Let's just call this an n-dimensional array object with n dimension and shape. And those are the things we want to solve for. The last one we actually did some shape and we did some data types near the end, but I figure why not just pick up from that, and we'll start this one with creating ND arrays, which is the section of this. And maybe once again I should put that in to match this, creating, and we'll just capitalize it, ND arrays. And we probably should say creating ND arrays, and with hops for Grasshopper. And that's exactly what we're doing. So we can shuffle this down. This will be our first script. And we'll just do one at a time and see how many videos come out of this video series. I do have kids at home. It's going to get a little loud. We're going into summer. I've got one more day of work and I can hit this full time. If you want to support it, you can go to wickersonstudios.com and you can start downloading any of these source files or any of the past research. But I think this one I'm doing pretty well with video tutorials that walk you. And then I also do some really cool data visualizations in the blue, which will get more and more complex and show you why vectorized or and array computations are going to speed up what you do in Grasshopper. And it is for the advanced Grasshopper person that's not so obsessed with plugins or writing them, but you actually just want to work from calling functions out of Visual Studio Code with the GHOps server and Flask as the middleware. And that's what I've kind of gotten used to doing, and I'm really enjoying it because I think functions need to stay extremely simple. So without further ado, let's get our GitHub Copilot going. I hope it's up and running. We are going to do a multi-dimensional NumPy array with n, dim, and shape. And what I'm going to do now to make this a little easier on people, before we write it into that component, we'll do that later on. Let's tab through that. But before we write that into a component, let's start using our terminal to debug things and make sure things are working. So the first one's going to be hard-coded, and we're not going to actually write that one into a component. But let's set it up as an example. So example one of a multi-dimensional NumPy array. And we will start with typing in a data, and we'll just call data 2 just for the sake of it. It will hard code in because it's coming out of textbooks and it's following that. A NumPy array that I actually want 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 3 lists making up an array. And I want to print that, and you're going to see that down in the terminal when I run it. But before we run it, I want to also show you that instead of printing data 2, before we do that, that's one way to do it. We could also, well, let's print the data, but we could also call the array to make a copy. Array 2 equals a NumPy array of data 2, and we should be able to then print, we can do things to that variable. So we're going to print that, but we're also going to print the nth dimension of that, and we're going to print the shape of that. And that will before we wrap that into a Grasshopper component, which I might do now, but since it's hard coded, what's the point? And it's actually telling you what that's going to be. You can always cheat because GitHub Copilot's so awesome. You just returns 3. It tells you exactly what you can expect, and this is why I like this, and returns 2 because that's a 2-dimensional array. So that's it. And that'll solve your answers for what kind of multidimensional you're using. So would I write it into a function? Probably not. I'd probably hit save and run and see what we have here. Let's give it a second. And there you go. You got your 2 and you got your 3, and there's your array. So that's it. We can leave that. I probably don't want to write that into a component. So I'm going to continue. And with that, I might... would I write it in? I'm not going to write it in with that data. I'm actually going to write it into the component with lists that I can input in the same way that I was writing lists before. So this one, I think I'm going to, before I get into zeros and ones arrays, we're actually going to write a hops component with shape, write this into a hops component. And I don't want all that junk. I'm going to write that into a hops component, but we're going to use lists. So we're going to hit that NumPy array, a hops component. It's going to be, we're going to call it the NumPy, dim, and, oh, there we go. Let's make sure that, no, that's not going to match anything we've done before. So it's going to call an n dimension and a shape. And that's exactly what it's going to do. It's going to come through with its description. Its inputs, we're actually going to build a list to start. 1, 2, 3. It's so amazing that you train your data. However, yeah, that'll be enough to start. And that'll close our inputs. Our outputs will tab through and enter through. We will get our array outputs back as 1, 2, 3. But we also want our strings back of our nth dimension, and we want our string back of our shape. And that handles tuples and different data types. We can always convert back over after, and we can do some fancy footwork. I think that's it. And it's going to bring in array 1, 2, 3, which are really just lists. And we have, let me see that I get it. I'm not using the list anymore. I'm still going to use what I had. I am going to array 1, 2, 3, print the array. I might print the data type. I do have to set a variable on here, the type of that. You have to set a variable here so you can do things with it, or at least that's what I found. I am going to put them over to strings here for safety. And with that, I've got my shape, my dimension put into a string. I can turn those into lists. It looks like that's going to output list out, which is all 3 of those list parts, then the n-dimensional array and the shape array. I think I'm pretty secure, but then again, whenever I'm confident, I usually screw up. And for good luck, I usually clear my data to feel nice and fresh, and I say, let's do it. And let's save and run, and hopefully it'll run and give us an IP address. And then what I'm going to do is, because I'm dealing with 3 lists in, I'm going to go back over here and see if I had anything that I was working on last time that had 3 lists in. Definitely this one was enough to start. I'm just going to grab that data right through the entwine. Just going to pick that all up, and I think I might pick up, there's my instructions. That should actually be over here. I'm not sure how I lost that. The other information I want to pick up is this. So I'm just going to tag that and bring it up here, put it here. And I think I can grab, I don't need that because I've already got the name. I'm just going to grab all this data here. I'm going to copy it, paste it. I'm going to slide it back over here, and hopefully it'll come over where I need it. I'm going to bypass all that stuff, drop it right in here. I've got my 3 lists in being generated, nice and simple. I can erase this. I've got my IP address, and I did some fancy footwork there. So I was buzzing around doing stuff. Let's get the IP address. I think we'll be fine. Let's grab our little hops node. Let's plug it in there. Let's /. Let's do the call on ndim and shape. Copy it and paste it. Hopefully we get it. It's looking pretty good. It's looking pretty jazzy. Let's put in our 3, but we're actually starting to do things with arrays and see what turns out. There's our 3, and we should be left with a couple of call functions for the dimension, which is 2, which is what it's supposed to be, and I can use that as a data type that can be used over into Grasshopper. And with the same breath, I can pull out my shape. And it should come out in 2 numbers, I think. No, it comes out as a string list. So it's just going to share with me those dimensions. But if I want to use those numbers, you'll remember what I did last time. I had to funk them around. I probably wouldn't turn them as a string. I might have to output them as a list. I'm not sure if I'm happy with that, but just to prove that that is a tuple and it's hidden in there, you can see that that's how it's reading. Let's leave it like that for now and get to the details if we have to do something else with it. So I'm going to left click. I'm going to grab my, I'm 100% happy with that because I want to put this into Grasshopper. That's really the point. And so I want to have data that I don't have to do any text control on it after. And then I'm just going to go here and we'll just leave that as a little bit of a something that might be what we want or something we might want to change later. And that's it. That gets us started. It rolls us through and we can now start looking at things that even though they're strings and we want the shapes and we want the dimension of these things, I think I'll leave it because that's how I did it in my first one. If we have to change it for later working, certainly when we get into pandas and deal with data frames, we're going to want data that can actually run right in the Grasshopper. But I'm pretty happy with that. I've got my output. One thing I want you to do for debugging is take your cached server off and cached memory off. Periodically take off your preferences and always make sure you take that check off the hide Rhino compute console window. You don't have to, but I would recommend it. So now when we're rolling through samples and checking this out, you can see it updates really live and lovely here. And that's really nice and fast in that. You don't cache anything, so it takes a little long, but it's moving pretty fast to do that. So that's it to start. What we're going to now get into is some of the things familiar to people working in NumPy in IPython or working in any one of the Jupyter frameworks. But we're going to take a look at NumPy 0 arrays and NumPy 1's arrays. But for right now, I'm going to take a little breather, put this one up online. If you want to support this, you can support it on Patreon. If you want to support what I'm doing here, just buy it and follow along. Hopefully when I'm done the full series and can sell it for a decent price completed, we can do that before moving on to maybe advanced NumPy or jumping hard into pandas. Once again, Michael Wickerson at Wickerson Studios. Stop recording.